So here we go with the 6.4b notes, the more complicated factoring. Last week you had the factoring review in which hopefully you were taught the snowflake method. If you were not taught the snowflake method for some reason, I am probably going to make a video about using the snowflake method using those 6.4a notes. I will put it in the School Loop locker probably, maybe Monday or Tuesday, so that you can go back and look at that if you want to for extra help. So this is 6.4b, and I have the first example written out. Sorry I couldn't get the actual document up there, so you'll just have to bear with me, but this is the problem that's on your notes. And the first thing you want to do with any of these factoring things, and it kind of says it up at the top, is you want to factor out the greatest common factor. Another way of saying that is look for what they have in common. So if I look at all the x's, I have x to the third, x squared, and x, and then this guy doesn't have one. So do they all have at least an x that I could take out? No, because this guy's got 3, 2, 1, but that guy doesn't have one. If there was an x on this last guy, then I could take something out. Okay, so we've looked at the x's. What about the numbers then? 4, 28, 3, and 21. Is there anything that all of those numbers are divisible by? No. So we can't take anything out. You always want to check if you can take something out first because it usually makes things simpler at that point. So I know I can't take anything out. I do notice that I have 4 terms here. If I have 4 terms, I can't use the snowflake I cannot use. So 4 terms, we use something called grouping. And hopefully this is a review for you from last year. If I have 4 terms and I'm going to use grouping, the first thing I do is I cut it in half right there. Notice I cut it in half right before that plus sign because the plus is kind of glued to that 3. So the first thing I'm going to do is I'm going to look at the 4x to the third minus 28x squared. And I just want to look at those terms. I'm going to ignore this guy for right now and just look at that first part. So what does 4x to the third and negative 28x squared have in common? Well, I can take out a 4 because they're both divisible by 4. I can also take out an x squared. Now if I take a 4x squared out, what is left? In other words, if I were to distribute this, what has to be here if I'm going to multiply to get 4x to the third? Well, 4x squared times x would give me 4x to the third. So that's my starting place. Next thing I need to know is if I took out 4x squared, what would be left for negative 28x squared? Well, 4 times negative 7 is negative 28, and x squared times 1, I don't really need to put a 1 there. I can just close my parentheses. So I've taken out everything that they have in common there. Now, let's go back to here where I drew a line through it. Probably shouldn't have drawn a line through it. Let's see if I can fix that. Good enough. 21, and that's a minus 21, I believe. Okay, so back to fixing that. What do these two terms now have in common? Positive 3x and negative 21. I believe they have a positive 3 in common. Now if I took out the positive 3, what do I need to multiply by, or what would be left over? Positive 3 times x would get me that positive 3x, and positive 3 times negative 7 gets me that negative 21. Now, if I did grouping correctly, this parentheses right there should match that parentheses right there. That was a really terrible highlighting job. Do you want to see that again? This parentheses right there needs to match that parentheses right there. As long as they match, then I am good to go. Now, we're almost done. However, this is the part that people mess up on a little bit. When we have our final answer, we are still going to have 2 sets of parentheses, just like we did when we were using the snowflake before. These two, because they are the same, they get grouped into becoming one of the 2 parentheses. Okay? When I get back to class, and I can explain a little bit more why they only represent 1 parentheses, but they do. My other parentheses I get from these things that I took out. So I have 4x squared and plus 3. So that right there would be my answer to the grouping. Now, when we are factoring, one thing that's helpful is we can always check our answers. So if you are unsure if you did this correctly, you can always multiply it out. 4x squared times x would be 4x to the third. 4x squared times negative 7 would be negative 28x squared. Positive 3 times x would be 3x. And positive 3 times negative 7 would be negative 21. And that was the original problem, wasn't it? As long as that's the original problem, I know my answer is good. Okay? All right. So, okay, and magically I have the next example written up here. 3x to the third plus 6x squared minus 75x minus 150. This is the example that's on the top right of your notes. Again, first thing I got to check is what do they have in common? Now I notice the x to the third, x squared, x, and because that guy doesn't have an x, I can't do anything with the x's. But 3, 6, negative 75, and negative 150 all have something in common. They all have 3 in common. So I can take out a 3 first of all. So let's see. 3 times x to the third gets me that 3x to the third. 3 times positive 2x squared gets me 6x squared. 3 times negative 25x gives me negative 75x. And 3 times 50, or negative 50 I should say, gets me that negative 150. Now, what's in here? Is there anything left that they have in common? No. That means I took out as much as I could. That's a good thing. So, I'm going to use the grouping on what's in the parentheses there. I just need to remember that at the very end, when I have my 2 parentheses, I have to put that 3 out in front of those 2 parentheses. So I'm going to ignore the 3 for right now, but I'll come back to it. So, 4 terms using grouping, I'm going to cut it in half and look at my first 2. What do those 2 terms have in common? X squared. So I take out the x squared times x gets me that x to the third. X squared times positive 2 gets me that positive 2x squared. Over here, now this one's a little bit different because this is a negative sign. In my previous example, we didn't have a negative sign there, we had a positive sign. Now, because that's a negative, I have to take out a negative number, okay? I cannot leave it with just a plus. So negative 25 and negative 50, I can take out a negative 25. So now negative 25 times what gives me negative 25x? Positive x, right? Negative times a positive gives me that negative 25x. And then negative 25 times what gives me negative 50? That would be a positive 2, because a negative times a positive gives me that negative up there. Okay, did I do it correctly? How do I check? My parentheses match. So if they match, I know I did it correctly. So this comes down to my 2 parentheses. These 2 right here become one of my parentheses. And my other parentheses is x squared minus 25. Couple things here. I can't forget that 3 that I took out way in the beginning. He's got to stay with it. The other thing I notice is I'm not done here. That's what we call a difference of squares. Hopefully you learned about that. If not, you can watch the snowflake video. And I'm making parentheses that are way too big there. I'll explain the difference of squares. X squared is a square number because it's x to the second, and 25 is a square number because it's 5 to the second. So that can be factored into x plus 5 and x minus 5. So that guy actually goes down further, and then I have my x plus 2. So my final answer to that problem is right there. Okay, so that's what we call factoring using our grouping method. All right, on to my next 2 problems. I have x to the third minus 64x, and then the one right next to it to the right is x to the third plus 64x. So again, first thing I have to check always is, do they have anything in common? Now with an x to the third and an x, I have an x in common, so I can take that out. What's left inside when I take that out? I have x squared minus 64. Now, what do we know about the number 64? Well, it happens to be a squared number. Isn't 64 the same thing as 8 squared? That means we have a difference of squares. So I'm going to have two parentheses there. I'm going to have x and 8, x and 8. One's a plus, one's a minus. Again, you can watch the snowflake video on that guy. If you want to see the snowflake for that one, you would have negative 64 on the top, and since there's no b value, you would have 0 down there. The only way to get that would be negative 8 and positive 8. Put your x and your x, and you have x minus 8 and x plus 8. So that's a pretty easy problem. And now let's go over to the other one, the x to the third plus 64x. This one's a little different. They still have an x in common, so I can take out an x, but this time I'm left with x squared plus 64, and that is a problem because it's not a difference of squares. If I were to try and snowflake that, I have positive 64 on the top, and my b value is 0. How do you get positive 64 by multiplying two numbers and have those two numbers also add up to 0? Well, 8 and 8 are your only possibilities, but the only way to get 8 and 8 to add up to 0 is to make one of them negative. And as soon as one of them's negative, that can't be a positive 64. It has to be a negative 64. So you can't even make a snowflake that works for that, which means that's as far as that guy can go. That guy's stuck. Now, there's something that we didn't mention about this this problem, which is kind of interesting because 64, I mentioned, was equal to 8 squared. 64 is a very special number because it is also equal to 4 cubed. So 8 squared was what we were thinking of when we were looking at the difference of squares and the sum of squares. We're going to learn something new now that will allow us to deal with cubes, and we will actually be able to factor it further. And that leads us right into our next example. So here we go. Our next example, x to the third plus 64. You know, this is very similar to the one before it. We took out the x, but we got x squared plus 64. As soon as we have x to the third, we have something dealing with cubes. Now what I mean by cubes is I mean that x to the third is equal to something to the third, and 64 is also something to the third. Now what I have to figure out is I have to figure out what goes in these little boxes. So, what is it that when I raise it to the third power gets me x to the third? Well, it would be plain old x. X, when I raise it to the third power, gives me x cubed. Then in my other parentheses, what is it that when I raise it to the third power gets me 64? 4. So 4 is what you raise to the third power to get 64. As soon as I do that, there is a formula I need to use. And there's actually two formulas. This one, since it's a plus sign, is going to use something we know as the sum of cubes. Now you're really going to want to write down this formula because you're going to need to know it for the test. The sum of cubes says that if you have something to the third power plus another thing to the third power, this is how it factors. It factors into the first thing plus the second thing, followed by first thing squared minus the first times the second plus the second squared. Now that's kind of ugly. This is what the problem looks like. This is what your factored answer will look like. Okay? So take a second and copy that down. And for our example, what is it that we have for A? Do you notice that this right here, if I put parentheses there, that's what I've got going on right there? And that right there is what I've got going on right there. So I just need to take this and plug them in for all the A's and B's in the formula over there. So for my problem right here, I'm going to use wherever it says A, I'm going to put in an X because that's what I have right there. Wherever there's a B, I'm going to plug in a 4 because that's what I've got in my problem. So when I plug that in, A plus B would be X plus 4. Hopefully that makes sense. A squared, well, if I took X and I squared it, what do I get? I get x squared, minus a times b. Well, what's x times 4? 4x. And finally, plus b squared. Well, 4 squared is 16. Now, that's kind of a pain. However, it's really simple once you get the hang of it, once you practice it enough. When you start getting really good at factoring, you might start looking at this and going, huh, that looks like something I might be able to snowflake. Do I need to check if I can snowflake that? Let me say that again. You may ask yourself, do I need to check if I can snowflake that again? Usually the answer is yes. However, when you use the sum of cubes formula, you can be done right there. The reason is, after you've used the sum of cubes formula, you will never be able to factor that. If you were to try and snowflake this, you will never have two numbers that multiply to 16 and add to -4. You can sit there and think about it if you want to, but it's not going to work out. So save yourself some time and know that once you've used your sum of cubes formula, you are done with the problem. Okay? So, sum of cubes, I told you there were two formulas. There's one other called the difference of cubes as well. Now, it's almost identical. Difference of cubes says if you have a problem that is in this format, a cubed minus b cubed, this is how it factors. It factors into a minus b, and then a squared plus ab plus b squared. Now, I want you to notice these two formulas. They are almost identical. A and b in the first parentheses for both of them. A squared and then ab and then b squared in the second parentheses. The only thing that's different is where the positives are and where the negatives are. Okay? Now, I'm going to try and explain this right here. If this helps you remember, great. If it doesn't help you remember, then forget about it. But someone once told me about this acronym called SOAP. And this helps me remember this. The S means that the first sign right there is the same as the sign in the problem. So if it's a difference, your first sign is a subtraction. If it's a sum, like up there, your first sign is a plus. So S means same. O means opposite. The very next sign is opposite. So if your first one was a subtraction, your second one is now addition. Up above, if your first one was addition, the second one is subtraction. And then AP means that the last sign is always positive. So if that helps you remember the signs, great. You still need to remember the order in which they come, the A, B, A squared, AB, B squared, all those guys in there. But you are going to need to know those two formulas for your Mod 6 quiz, which I don't know off the top of my head. Could be the end of this week. Could be Friday, but I'll check on that for you. Okay, so let's move on to the next problem. So here's our next problem. 8x to the third minus 125y to the 6th. Now I did say, excuse me, whenever you can, find if they have something in common. I see an x and a y, so they don't have that in common. 8 and 125, I'm pretty sure they don't have anything in common. But I do see cubes. So again, I'm going to set it up as something to the third minus something to the third. Now I got to figure out what I put in those parentheses. So let's see. What is it that when I raise it to the third power gets me 8? Well, that would be 2, because 2 to the third power gives me 8. What is it when I raise it to the third power gives me x cubed? X. So in other words, if I were to take this and distribute it, 2 to the third is 8, x to the third is x cubed. That's what gives me 8x to the third. So in my formula from the previous slide, whenever there's an a, I'm going to use 2x, because that's what I got there. Over here, what is it that to the third gives you 125? That would be 5. And what is it that to the third power gives you y to the 6th? Think about that for a minute. That would be y to the second, because if you distribute, 5 to the third is 125. Sorry, my cuckoo clock's going off if you can hear that. And when we distribute an exponent there, we would multiply that. So whenever there's a b in the formula, I'm going to have to use 5 y squared. So if you notice, a and b are a little bit more complicated than they were before, but I'm still going to use the same formula. So the difference of cubes said on the previous slide that a cubed minus b cubed is the problem, and we do have that formula. We do have something cubed minus something cubed. That's going to factor into a minus b, a squared plus ab plus b squared. So now I just got to figure out how to put this into that. First parenthesis should be easy. A minus b would be 2x minus 5y. Just substituting in what a is and what b is. What gets a little tricky is this second parenthesis. I need to square a. Well, how do I square 2x? Let me think about that for a minute. If I take 2x and I have to square it, I have to square both the 2 and the x. So that actually gives me 4x squared. A lot of people will lose points there because they will forget to square that first number as well, the coefficient. Now I'm going to put a plus sign, and this middle term would be a times b. So I have to do 2x times 5y squared. I think that gives me 10, xy squared? And then finally plus b squared. So just like I did with a squared, I have to take b squared, or b, which is 5y squared, and I have to square it. So squaring the 5 squared is 25, and squaring the y squared gives me y to the 4th, because you have to multiply those exponents. So I have 25y to the 4th. Okay, so that one was ugly, but the process is the same. The numbers were uglier, but the process was the same. Okay, all right, let's move on to the next one. All right, just like the previous ones, I gotta look and see what do they have in common. Well, between the 2 and the 54, I think I can take out a 2. Between x to the 18th and y, I can take out a y. What does that leave me with? It leaves me with x to the 18th minus, see if I take out a 2, that becomes 27, and the y goes away. Now, x to the 18th is kind of crazy. We don't usually deal with exponents that high. But I know that this is a cubic number if that exponent is divisible by 3. As long as that's divisible by 3, I've got a cubic number. Is 27 a cubic number? Yes, indeed, it is a cubic number, because it is 3 to the 3rd. So I have something to the 3rd minus something to the 3rd. Now because I took this 2y out at the very beginning, just like we did in a previous example, I think it was the second example, I'm going to have to remember to put that in front at the end, otherwise I'll have it wrong. So next thing I need to do is I need to figure out what is it that to the 3rd power gets me x to the 18th. Well, I know it's x. Now I got to remember, I would take that 3 and multiply it by the exponent to get that 18. Therefore, it's x to the 6th. And the second one, what to the 3rd power gives me 27? 3. So in my formula, wherever I see a, what am I going to be substituting? X to the 6th. And wherever I see b, I'm going to be substituting 3. So do I have a sum or a difference here? I think I have a difference, because I've still got a subtraction sign. So I have to use the difference formula, which is a minus b, a squared plus ab plus b squared. So a minus b is going to be x to the 6th minus 3. Now, just for future reference, I would want to see if this is a difference of cubes, I have an issue. Thankfully, it's not. Next parentheses, I have to take a and I have to square it. Well, how do I square x to the 6th? I multiply those exponents. What does that give me? X to the 12th. So that's what I've got there. Plus a times b. Well, what's x to the 6th times 3? That would be 3x to the 6th. Plus b squared, well, 3 squared is 9. Now, I'm going to box my answer, but don't make this mistake. We took something out at the beginning. I'm going to erase this right here because I need room to write it. We have to put back in the 2y that we took out at the beginning. If we do not put that in, we do not have our answer completed. Okay, it is not fully factored. Reason is because if I multiplied all this stuff together but I didn't include the 2y, I wouldn't get back to the original problem. I would get almost there, but not quite. In order to get fully back to the original problem, I have to include the 2y. So that's why I have to have that there. All right, let's do this last problem. Should be pretty quick. This last problem is pretty simple numbers to deal with, so hopefully we'll do it pretty decently. X to the 6th minus 7x to the 3rd minus 8. Now we did snowflake on this before, so we had negative 8 and negative 7, two numbers that multiply to get negative 8 and add to get negative 7 would be negative 8 and positive 1. We put x to the 6th and x to the 6th, so we ended up with x to the 6th minus 8 and x to the, I'm sorry, not x to the 6th, here I am making a mistake, it's been a while. That's not x to the 6th, it's x to the 3rd. There we go. And x to the 3rd plus 1. So again, x to the 3rd minus 8, x to the 3rd plus 1. Now, the reason why we can go further now is we have a difference of cubes and a sum of cubes. So we're going to take this actually two separate things. We have to use both formulas. So I have something to the 3rd minus something to the 3rd here. What is it that to the 3rd power gets me x to the 3rd? That would be x. What to the 3rd gives me negative 8? 2. Now if I use my difference formula, I have x minus 2, that's a minus b, and then a squared plus a times b plus b squared would be 4. So if I factor that x to the 3rd minus 8 using my difference of cubes, this is what I get. Now I'm going to do the same thing with this guy. That's something to the 3rd plus something to the 3rd. Well, that would be x to the 3rd. And what to the 3rd power is 1? 1. So now I'm just going to take these two, the x and the 1, and I'm going to put my factoring right next to it. So I'm going to start off with sum of cubes would be a plus b, or x plus 1, and then a squared minus a times b, 1 times x is x, plus b squared is 1. So this one is hideous because it's so long, but it does fully factor to that. Okay, so now that we know difference of squares, it's not okay to just stop there. You do have to go this full way and give me this big old ugly answer. Okay, all right, good luck on your homework. I am going to post the link to this video in the School Loop locker, so if you need to come back and look at it later to help you through tonight's homework, it will be there. Thanks.